Okay, so let's get started. Circuit is basically a pathway for the current to flow in. And circuit में दो चीजें हैं. एक, the way circuit is drawn, like the layout, that's one. And the second thing in a circuit is basically the components that you have. So every component is different in terms of how it behaves, what you can do with it, what you can achieve with it, the function that it plays. So that's the component. And the layout. Layout allows you to make sure that you use the least amount of energy, you deliver the highest amount of, you waste the least amount of energy, you deliver the highest amount of energy that you need, you fulfill the requirement of whatever application you have. That's the layout. And components are easy. Components you can study, and they're just simple behaviors. Like most components have two terminals. So there's the two terminal components. They have an in and an out. And usually what happens is one of them is positive and one of them is negative. When we say positive and negative, what we mean to say is that current is going from positive to negative. So if it enters, that's the positive thing. If it exits, that's the negative thing. So that's how we have the components. So most of the components like this are, you have bulb, and bulb is usually drawn like this. Current enters from one side, exits from the other side, delivers energy meanwhile. So that's the bulb. Then we have resistor, and resistor is like this. What happens here is that current comes from either side, and the resistor resists its flow. It doesn't allow it to go as it wants. What that does is that the current, as it's flowing, the charge has to give up energy as a way of going through it. So it's like the resistor takes the energy out of the charges that are flowing. And depending on how much resistance there is, the energy is distributed like that. Then some of these resistors are fixed. So this is a fixed resistor, but some of them are not fixed. We draw them out like this. And this is a variable resistor, or we can also call it a rheostat. So what a rheostat does is, like, the most basic rheostat would be that it has a wire in it, and you can control the length of wire using a knob. So if you rotate the knob, it is possible that the wire keeps on increasing. And if you stop, it's possible that that is the length that we have. And that is how you change the length of wire that you have, and that affects the rate of flow that you have. So this is a basically resistor. So let me show you a basic diagram of what a variable resistor might look like. So here's the thing. So if you notice over here, there's this terminal that the current is coming in from. Okay, so there's it coming from in here and it's going out from in here. So when it comes in, it goes through this wire like ऐसे चलता up till it comes to this sliding terminal and goes out from there. Now, if I were to slide this thing, and if I were to bring this sliding contact over here, what that would mean is that now the current has to travel all the way over here and then go from here to here. So the number of wires, that the number of coil that it has to go through, that is changed based on where the sliding contact is. And that is how the resistance that it goes through changes. So that's a basic variable resistor. We also use this symbol for it, that, yeah, this one, if I'm not wrong. But some of these don't just, sorry, this is not the symbol for this variable resistor. It's a different one. That one is basically this. And this is supposed to show a sliding rule, that wherever this arrow is, that is where it's a sliding contact that you have. The resistor, most commonly, this one is used in our houses when you have those fan speed adjustment के लिए buttons नहीं होते houses में, और bulbs की brightness को control करने के लिए जो होते हैं, like chandeliers वगैरह के लिए. Those are basically your variable resistors that you have. So they allow a limited amount of current depending on how much resistance that they have. Then we have some variable resistors that depend on external quantities. Like this is a thermistor. It's a variable resistor, but it depends on heat. So if you have high, like a large temperature or high temperature, it has a lower resistance. And if you have a low temperature, it has a high resistance. Similarly, we have LDRs. LDRs are basically these things. They get light, and ज़्यादा light होगी तो उनकी resistance कम हो जाएगी, कम होगी तो ज़्यादा होगी. Zainab's comment is the coiled wire in contact with each other, so won't the charge just pass over it rather than going along the coils? Yeah, it is possible, but then we have to see that where is the terminal connected. If I were to connect the terminal over here, like इधर से current आया और इधर से चले गया, then it doesn't matter where the sliding rule is. It's going to use the whole thing. But if that one is not open, like not closed, इधर कोई चीज ही नहीं आगे लेके जाने वाली, तो करंट यहां से ऐसे निकल जाएगा. When the current reaches this point, it has two paths, either to move on or to go forward. And if there is a dead end here, current does not move down. Potentiometer is a way of measuring voltages for two things. So rheostat is used to make a potentiometer or a potential divider. So don't worry about it. We'll see how we can use a rheostat to to make a potentiometer. So this one is called a light dependent resistor, or LDR. What it does is that if you have a high light intensity, it has a low resistance, and if you have a low light intensity, it has a high resistance. So these are some basic circuit components that you have. Obviously, resistance, we measure it in ohms, and there are many different types or shapes of these components that you can get. There's obviously other things like switches. So this is a switch. Right now it's open, which means current cannot flow. And now it is closed, which means current can flow. Then there is the battery, which is basically a collection of different cells. So एक अगर एक pair होगा तो वो cell है, दो या दो से ज़्यादा होंगे तो battery है. It supplies DC or direct current. Then there is this, it supplies AC or alternative current, which is why it doesn't have a positive or a negative side, because it keeps on switching between them. So for half a cycle, one side is positive, and for the next half, the other side is positive. So what exactly do resistors measure? Resistors measure potential difference. They allow us to measure potential difference. A potential difference क्या होता है? So remember that charge is conserved. Charge is a physical thing which enters a circuit, which enters a component, and it exits from it. So it's not like something is going to withhold charge. There is one thing that does that, and we call it capacitor, which stores charge for some time, but that we don't study in O levels. We do study it in IGCSE. So I can keep a session for that for those like Maheen, you are the one in IGCSE. So we can.
I'm the only one, sir.
So we can study it there later on. नहीं HSN के बच्चे होते हैं वो IGCSE कर रहे होते हैं. Yeah. So a capacitor, which is written like this, which is drawn like this, two parallel lines. This is the one that stores charge, but the rest of it, they usually don't. They just allow the charge that comes from one side to go out from the other side. So when the charge enters, it has some energy in it. But because the resistance is being offered, वो energy use up हो जाती है. And when the charge exits, जितनी energy बच जाती है, we subtract them to find the potential difference. It's simple. Difference because we want to see how much was used up from entering the resistor to exiting the resistor. So this is about components. There is another 3-terminal component. There's only one in your syllabus, which is basically made using these junctions, like PN junctions. And most teachers, they just skip that component. I don't know why, but usually it is just like not studied. इस तरह से करते हैं. उसमें बेसिकली आपके पास क्या होता है कि वो बेसिकली एक ट्रांजिस्टर होता है. ट्रांजिस्टर में क्या होता है कि आपके पास तीन चीजें हैं. You have three components. So transistor is like this. There's this one, there's this one, and there's this one. Sometimes what we do is we draw it like this. So we have this. Sometimes we draw it like this, that it has three terminals, and we use those three terminals in a way कि एक करंट एक साइड से करंट आता है, दूसरी साइड से करंट जाता है, और एक साइड उसको कंट्रोल करती है कि वो आएगा कि नहीं आएगा. So usually when you draw the symbol for it, वो symbol इस तरह से होता है. This is basically supposed to be a base, and this is where the current comes in, and this is where it goes out. ठीक है? So this base is going to act as a gate, I would say, and allow things to come in or not come in and all that. So this is a basically transistor. Transistor को most teachers skip, but I can teach you if you want to know it. क्योंकि एग्जाम में हमेशा इसका क्वेश्चन जो आता है ना वो ऑप्शनल आता है. And the symbol that they use in exam is neither one of these. It's basically a circle with a line and this thing. So it's an arrow like this. This is supposed to be a transistor. That's what you get in the exam. So this is the only three terminal component that you have in your syllabus. ठीक है? अब आ जाते हैं. Obviously, we'll study how each of them individually works. LDR थर्मिस्टर का मैंने आपको बता दिया. वेरिएबल रेजिस्टर का भी हम देख लेते हैं कि यूजेस क्या हैं, और थ्री टर्मिनल वाली को भी हम देख लेंगे. लेआउट दो तरह की होती है. लेआउट बेसिकली इज हाउ यू ले दीज थिंग्स आउट, एज द नेम सजेस्ट. क्या मतलब आपका नेटवर्क नजर कैसा आता है. सो देयर इज द सीरीज वन एंड देयर इज द पैरेलल वन. Series means that all the things are connected and the current goes in them one after another, just like a series, a TV series or a domino blocks and all that. कि मतलब अगर वो एक में आ गया तो वो अगले में भी जाएगा ही जाएगा, उसको रोकने वाला कोई नहीं. एंड पैरेलल मींस कि जरूरी नहीं है कि एक पाथ में से गुजरे. देयर इज अनदर पैरेलल पाथ अवेलेबल and the current can choose which path to go in and which paths to not go in. So in series you have just one path, and in parallel you have multiple paths. So what we have to understand about these is what is constant in them and what changes in them. So remember one thing, that current, if it is flowing, then obviously इसने गुजरना ही गुजरना है. But current has a weird relationship with resistance, that if there is high resistance, current tries not to go there. There is less current. ठीक है? So resistance वो है जो रास्ते में उसको रोक रही है. And the best way of looking at it, like the example that I usually use to visualize these things, is that charge is basically a car, and it goes out of a house carrying people, and a car just transports people and stuff. So resistance is basically the problems that might be caused by traffic or road quality or that kind of thing. तो जितना ज्यादा resistance होगी, it is more difficult for the driver to actually take the car out. अगर riots हो रहे हैं तो वो बिल्कुल भी नहीं निकलेगा क्योंकि resistance बहुत ज्यादा है. ठीक है? और अगर स्मूथ और बड़ी जबरदस्त ट्रैफिक है और खाली शहर है तो वो निकल के जो मर्जी करे. So that's one thing that I think of. Similarly, series and parallel simply means the road network that you have. Parallel means there are multiple ways of entry and exit. And series means there's only one way, one path. So let's suppose I have a basic circuit. This circuit is one bulb, one resistor, one battery. So if I had a series circuit, let me see what will happen. So I need to know the behavior of four things: current, voltage, resistance, and power in this circuit. That's what I need to know, okay? So in series, let's suppose I have a battery. So let me draw a battery, sorry. So I have a battery, it's just one cell, and I have a bulb, and I have a resistor. And this is how it goes. I have closed the switch, its current is flowing. ठीक है. अच्छा, सीरीज और पैरेलल के अलावा एक और सर्किट होता है, उसको हम शॉर्ट सर्किट कहते हैं. Short circuit is a circuit in which there is no resistance. So short circuit is the one in which there is no resistance. अच्छा, तो मतलब अगर मैं कहूँ ना यहाँ से लेके यहाँ तक, so it's a short circuit because there is no resistance in this path. So the current comes in, doesn't have to spend any energy on it. So current यहाँ से निकला, from the positive terminal current निकल आया, चलता गया चलता गया चलता गया up till it reaches this point. This is where the current has to go into the bulb. And right now it has a higher energy because उसके पास काफी एनर्जी है जो वो लेके निकला हुआ है. और जब वो इसमें गुजरेगा तो it will deliver that energy to it because bulb will take some energy out and not allow it to take all of that with it. So हमारे पास we can check how much that is by using a voltmeter. So if the voltmeter reads 2, that means that every charge that's coming in is losing 2 joules there. That bulb is taking 2 joules out. Now the charge that comes out here, so if this was A point and this is B point, so at B the number of charges are exactly the same. कोई charge bulb के अंदर रह नहीं गया है, लेकिन the energy that they have that has gone down. Similarly, यहाँ पर आता है C point, it enters it, exits from D point. I can see how much energy has been given away by the charge. And this is basically again that the charges that came in at C are the same charges that went out at D. And then that charge comes in, enters the battery. यहाँ पर भी उसकी voltage होगी, which is basically the difference in how much energy it brought in and how much energy it went out with. This component, battery, is opposite to the behavior of resistor. Because resistor it loses energy. It has a higher energy when it enters and lower energy when it exits. But in battery, it's the other way around. It has a lower energy when it enters and has a high energy when it exits. So यहाँ पर if I were to see के overall कितनी energy loss हुई है, so in any one loop, remember this thing, in any one loop that you have for a circuit, the total change in energy is 0. So you can think of it as energy given is the same as energy taken out. Okay. Now think about it. If I were to divide all of this by charge, so the charge that took the energy is the same as charge that delivered the energy. So वो तो same है. And this makes it voltage given is equal to the voltage taken. And voltage given is basically the EMF. And voltage taken is basically the potential difference. So the total EMF in a loop is the same as total potential difference in a loop. So in this loop, what is constant? The current that passes through. And what is the overall behavior? The overall behavior is that whatever voltage is of the battery, that is the same as the voltage of individual things. So that's the first rule that we need to know about. That the total voltage that is given is the same as total voltage that is taken. Usually in the book, they sum it up by saying that V total is the voltage 1 plus voltage 2 plus voltage 3. And that makes sense. Total energy loss कितना हुआ है? Individual चीजों का loss देख लो. So I can say that V total in a series circuit is sum of V. And same way, resistance total क्या होगी? मेरे पास V total क्या है? It is the current total current times total resistance. अच्छा ठीक है. What is V1? अगर मैं बल्ब को देखूं तो बल्ब के अंदर कितना करंट आया था? I. और रेजिस्टेंस कितनी थी? बल्ब की रेजिस्टेंस. तो I1 R1. सिमिलरली अगर मैं रेजिस्टर को देखूं तो करंट कितना आया था? I. और रेजिस्टेंस कितनी थी? R2. But if you notice, the total current that entered the bulb is exactly the same as the current that entered the resistor. So I can say that current that entered, the total current is the same as current that entered the bulb times the resistance of the bulb plus current that entered the resistor times the resistance of the resistor, which basically means that I can take this I here, IR total is equal to I bracket R1 plus R total. And that means you can cancel this R out. So that leaves me with this idea that the total resistance is sum of resistances. Similarly, I already know that total voltage is sum of voltages. In any loop, the EMF given in basically energy कितनी दी थी उतनी है जितनी energy उसने ली है per unit charge. And that's the idea of what a series circuit is like. What is not changing? The current, because throughout the loop एक ही amount of current है जो कि flow कर रही है. But things change in a parallel circuit. अच्छा power का behavior क्या है? Because energy per unit time is the same, so power given in is the same as power taken out. अच्छा अब जरा parallel को देख लेते हैं. Parallel maybe we need to know about these four things. And what exactly is a parallel thing? Like a basic circuit would be like this, that I have a resistor that's connected to a battery, but I connect a bulb to a battery as well. और ये यहाँ पे ऐसे join हो गया. Now imagine a current coming out like this from here. So current यहाँ पे आएगा and over here current has a choice. It can either go in this direction or it can go in this direction. So here we have the second idea that because charge is conserved, the current that is coming in is the same as current that is going out at any point. So इस point पे जितना current आया है उतना ही बाहर गया है, regardless of which path it takes. Now, how does it decide which path to take? The path that is least resistance gets the most current, which makes sense. अगर एक रोड सबसे अच्छी है और वो सबसे तेज है और जल्दी पहुंचाती है तो most people will follow that road. एक बुरी रोड है, most people will avoid that road. Just like that, if there is high resistance, current will avoid that path. So जितनी ज्यादा resistance होगी current उतना कम होगा उसमें. और यहाँ पे ये आइडिया क्यों है, हम वोल्टेज क्यों नहीं कह रहे? Because वोल्टेज क्या होती है? It is the energy per unit charge. हर चार्ज को कितनी एनर्जी मिली है? बैटरी ने तो हर चार्ज को उतनी एनर्जी देनी है. बैटरी ये तो नहीं करेगी कि इस चार्ज को ज्यादा दे दूं उसको ज्यादा दे दूं. वो डिस्क्रिमिनेट नहीं करती, सबको एक जितनी एनर्जी देती है. So we can establish that voltage is constant. Okay. So what changes then? It is the current that changes. And what does it depend on? It is dependent on resistance. And that is the idea that allows you to compare the parallel circuits. In series, it was different because series mein, it was the current that was constant. So we could say that voltage is directly proportional to resistance because current yahan pe constant hai. But over here, we have a slightly different thing. Voltage is constant, which makes current dependent on resistance. So जितनी ज़्यादा resistance होगी उतना कम current उधर जाएगा. लेकिन जितना भी जाएगा, let me call this I1, I2 and I3, then any path I take, wherever there is going to be division, I know that the current in, which is I1, it is equal to current out, which is I2 plus I3. What about resistance? क्योंकि यहाँ पे जब वो current आएगा, let's suppose यहाँ पे आया एक charge, उसके पास उतनी एनर्जी है जितनी यहाँ पे जो चार्ज है उसके पास एनर्जी. हाँ, इसके पास हो सकता है चार्जेस ज्यादा आ जाएं क्योंकि इसकी रेजिस्टेंस कम है, लेकिन हर चार्ज के पास एनर्जी उतनी है तो वोल्टेज कांस्टेंट होगी. What about resistance? Just like over here, we could say V total and R total were sum of all these. Just like that, over here we'll say the same. I total is sum of I1 plus I2 plus so on. And 1 over R total is the same as 1 over R1 plus 1 over R2 and so on. Why? Because the path that has a higher resistance gets more current. That's it. Oh, sorry, gets less current. Inversely related. Acha, if you have just two components, then you can say that R total is R1, R2 over R1 plus R2. That's a shortcut you can use whenever you have two components in a circuit. But if you have more than two, then you just remember that I is inversely related to 1 over R. So you add up all the 1 over R's and you will get the total resistance. Basically ये path क्या कह रहा है? ये कह रहा है कि overall अगर हम देखें तो people will value. So imagine लाहौर से इस्लामाबाद जाना है, अगर एक GT रोड ही है, everybody will be complaining. They'll be like यार इतना ज्यादा जाना पड़ता है, इतनी ख्वारी है, रास्ते में मसला हो जाए सारी रोड ब्लॉक हो जाती है. But in parallel, it would be कि अच्छा लाहौर से इस्लामाबाद जाना है, you have motorways, you have roads, you have railway, you have airlines. आप जिस मर्जी से चले जाओ, people will be like कोई मसला ही नहीं है. हाँ, GT रोड अभी भी वैसी है, मोटरवे भी अपने लिहाज से रेजिस्टेंस ऑफर करती होगी, बट ओवरऑल पीपल विल फील कि बड़ा कंफर्टेबल हो गया ट्रैवल करना. इंडिविजुअली हो सकता है वैसा कंफर्टेबल ना हो, लेकिन ओवरऑल हो गया. एंड दैट्स द आइडिया हियर, that in parallel overall resistance is lower. What about energy? So in parallel or in series, दोनों में total energy used is the energy used by individual components. सबके साथ को हम combine कर लेते हैं. तो power या energy used per time is the same depending on what components you have. But series का एक fault है. अगर कोई चीज सीरीज में है तो एक को भी अगर करंट पहुंचाना है तो वो सब में से गुजरेगा, सभी चलेंगे. तो फॉर एग्जांपल इफ आई हैव अ डेस्कटॉप, तो मैं एक स्विच से ऑन करता हूँ उसको, तो मेरा कंप्यूटर, मेरा स्क्रीन्स, इफ आई हैव अ चार्जर कनेक्टेड टू इट, एवरीथिंग जस्ट टर्न्स ऑन. बट इफ आई एम इन अ रूम एंड आई वांट टू टर्न ऑन माय बल्ब और द कंप्यूटर, देन दे आर इन पैरेलल. ये नहीं कि एक बटन ऑन किया घर के अंदर सब कुछ ऑन हो गया. Whenever you have parallel, it allows you to control individual components, but obviously it might get more expensive than having everything in series. फिर series का एक problem भी है, resistance adds up. So जो आपका सबसे ज्यादा resistance वाली चीज होगी, that is the one that's going to decide कि कितना current flow करेगा. But in parallel that's not the case. अगर बहुत ज्यादा resistance वाली कोई चीज होगी उसको current नहीं मिलेगा, बाकी सब चीजें चल पड़ेंगी. So that is why in houses we use parallel, या जहाँ पे भी हमने हर चीज को इंडिविजुअली कंट्रोल करना है हम पैरेलल यूज करते हैं, और जहाँ पे हमने किसी चीज को कंबाइंड कंट्रोल करना है, जैसे कि एक पूरा सिस्टम है जिसको पूरे को आप ऑन करना चाहते हो, then we use series. So that's the idea of circuit layout and how you can use it to figure out different pathways, behavior of a circuit and all that. And yeah, that's it for now. I would say कि आप इसको यूज करें और different circuits draw करें and try to figure out, are they series, are they parallel, are they a mixture, can you convert them to a series as parallel part, and then can you figure out the total voltage and the total resistance of the circuit. There are many examples in the book, तो आप उनको देख सकते हो, study कर सकते हो. Okay.